With traditional wind turbines limited by location and high material costs, the industry needs innovative solutions for clean energy in remote areas. This week, we speak with Mark Hoppe at SkySails Power. SkySails has developed a containerized airborne wind energy system that captures high altitude winds with unique kite technology, producing up to 50% more yield than conventional turbines while being deployable nearly anywhere on the planet. Stay tuned.
Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
Mark, welcome to the podcast.
Yeah, thanks, man. Nice to be here.
I've been looking to talk to you for going on at least 2 years because I saw SkySails in Hamburg at the Hamburg Wind Energy Show, and I thought, wow, this is really cool. And the display was good and the information was good. I just didn't know how much effort had gone into it at that point, and we're 2 years further along, obviously. The SkySails technology and the problem you're solving is really fascinating because there's a lot of places on the planet that could use wind energy, but a standard horizontal axis wind turbine is probably not the right approach, and diesel ends up being the winner on a lot of these places. That's a problem.
Definitely. So yeah, our technology solves a lot of these problems, but of course our technology is not just meant for these kind of places. So this is the entry point where we go in as these places, they face a lot of issues when it comes to logistics, prices of the diesel because of the transport costs that also includes in the diesel prices, which then makes the diesel even pricier. So and due to they have to spend a lot of money on the diesel, then they have the issue that they don't have the money for social development, for example, because they have to subsidize the power prices, and all this comes along. Um, so what we have as a solution for that problem is that we have a containerized wind power system. It's so-called Airborne wind energy system, which uses the high altitude wind, which is more powerful. So we fly in heights between 2 and 400 meters, sometimes even higher. Depends on the wind direction and everything. And due to that, we can use the high altitude wind and then produce 50% more yield than a typical wind turbine at the same size. So that's crazy.
Yes. That's really good. I think the technology and the approach is innovative. So the solution to get rid of all of the dependence on diesel and some of these electric grids that are very unreliable is to put in basically electric generation through a kite in a sense. The technology seems relatively simple, but I've looked at this up close. There's actually a lot of technology here because the system itself is really containerized. It's like dropping a diesel generator on site somewhere, but except it's a kite instead. You want to explain basically how the system operates and what someone would see if they're watching it work?
Yeah, sure. So basically, we always divide it into two subsystems, more or less. So we have the ground station, which is a container. It's a 30 feet container, so you can ship it everywhere and just need one truck to actually transport it somewhere. So this is really easy. And then you have the flying system, and the flying system at the ground station, they're connected via the start and landing mast. And the start and landing mast, so in the front of the start and landing mast, you have the kite. So when the start and landing mast goes up, the infloating wind unfolds the kite, and then the wind takes the kite upwards. And underneath the kite, you have a roboter. We call it the control pod. You can compare it to a paraglide pilot, more or less. And there you have an autopilot who steers the whole system. And then what it does is, I don't know, have you ever been kite surfing before?
Yeah, I've seen it. Yes.
Yeah. So when you have kite surfing, you try to fly your kite in the so-called power zone because you have the wind window. So in the middle of it, you have the power zone. There you have the most force. And the autopilot does the same. So it actually tries to fly inside the power zone all the time. So you have a lot of force on the tether. And when the tether is unwind from the winch inside the ground station, the rotational energy is converted into electricity. and then you have 800-meter long tether on the drum, and then when the 800 meters gone all the way out, the autopilot takes back the kite in nosedive, so it actually pitches the kite, and then it falls down from the sky, and then it has nearly no force, and then the generator acts as a motor and wheels in the tether again, and then when the autopilot is at 100 meter, it starts all over. So you can compare it to a yo-yo, you know?
That's a very good analogy. So the kite deploys out, several hundred meters, 800 meters, providing energy because of that pull force, turning a generator, and then when it reaches its extended length, it basically simplifies itself, lowers the drag, comes back in, and repeats it. So does that create continuous power then, or how does it handle the inward time in terms of power production? Is there a battery involved? What does that look like?
Yeah, so we always deliver our system in different configurations. So a little bit depends on the site conditions. So of course you can use it off grid. So what we would do then is we always deliver. So our system comes in a 30 feet container, and then you have another smaller container where you have a grid converter or a battery pack inside. And then so what we do with this solution is that we can always comply to the grid code, but also, of course, can deliver an off-grid system. So you can either store the energy produced or use it direct, or um, grid connect the whole system and then feed it into the grid. So that's up to our customers on this side.
I think that one of the important things here to think about, like in the beginning of this conversation of how this thing looks, how it operates in the field, is that it is modularized, right? Like you guys have taken the smart approach of putting this in a container because a lot of the places that this technology can be used can be on demand. Hey, in my mind, I'm thinking disaster response. I'm thinking military uses, remote microgrids. Like we've had on the podcast before. Hatch works with a lot of First Nations up in Canada, where they're in these really remote places. It's hard to get infrastructure in there, but if you can bring this in on a truck, great, right? So there's a lot of places around the world, and I know that's just one use case, right? These Caribbean islands, like Alan was saying, diesel generators, but they're paying exorbitant amounts of cost for fuel. So and the fact that you can switch over to different grids, right? So different hertz ratings and voltages coming out, really important. So where have you guys been able to deploy the system so far?
So far, and so far we have been installing systems. So we have one system in northern Germany, which is our research development site also. And that one has also been grid connected now for 5 years, more or less, and also been operating since then. But we use it for short iterations in our the research development cycle. Then we have another system which has been installed on Mauritius for now also 2.5, 3 years, something. Also with grid connection, which has been operated all the time because of duration tests. So we actually get some figures about, okay, how good, how lasting are our materials, and what do we need to do to make them even last longer. So we learned a lot in the past years on that, and now we take all this into our product development cycles. And now we have another two systems which are now being delivered to Taiwan. So the next installations will be in Taiwan, and then we have some projects going on in the Philippines, Cape Verde, Hawaii. So all of these like island states and island nations, we're really active in these spaces right now. French Polynesia is also really interesting. So far remote places. And all these island states, they have a big issue. They have the really big issue because they're feeding the climate crisis first. So they need to solve it. And also, and also what we are also looking into, which is a really interesting market, is the Caribbean, um, because there you have the same issues. You have a hurricane region. So what they have to do is that they have to rebuild more or less their whole infrastructure every 5 to 10 years because everything is being destroyed. So they can't even install any wind turbines because they've just been blown away. And in Mauritius, we have proven that our system actually is feasible to withstand a typhoon um, many times.
Well, and these are good places to do installs too, I suppose, from a business perspective. You get to go to the Caribbean or French Polynesia, like that. That sounds amazing. So, one of the questions I'd ask you is, kind of reviewing your technology here. Do you have a special kind of parachute material and a tether material that you guys use because it's long duration? In my mind, I think a parachute is down, repack, put away. But this thing is going to be out there for a long time. So throughout these great that you guys have had 5 year test and a 2 3 year test, have you developed those technology? How have those technologies developed?
So, well, it has developed a lot, and there's still a lot to do. So, because we still do a lot of material tests, and now we extend them by far what we have done before. So, when you look at the materials, what we use now is for the tether we use Dyneema, which is even used in the shooting vests, I think, and it's like it's even with it's better than steel, so it's actually made for a lot of force, and so you can think of we use a 40 millimeter tether diameter, 40 millimeter, and it withdraw it's made for, I think, 6 tons design load. And yeah, so it withdraws a lot. Then what we use for the kites, it's actually the same kind of materials what you use in sailing nowadays. And also what they do in development, when you look at the sails nowadays, also especially for the performance sailings, for the races, what they use there. This is these kind of materials we also kind of use, and also will extend, because they are made to last for a lot of force, but they're even light and all that what we need. And then, for example, what we have done now, so we just bought the biggest tether bending machine in the world to actually do the tether testing and to extend all this knowledge, because this is really important, also for the safetyness of our system, because everything is built around the tether. Yeah. So,
Well, Dyneema is the right choice there. That material has been proven over and over and over again in aerospace and in sailing. It is an extremely tough material. Yeah, you're only using a line that's about a tenth of an inch wide diameter. That's actually really small, but it does make sense because that's the right choice. Now, in terms of operational aspects, one of the things I get asked about SkySails is, well, how many hours a day does it operate? Is it up there 24 hours a day? Is it up there 5 hours a day? What do you typically see in some of these installations?
our systems, like looking over a year, I think it's good to compare also the different technologies when you look at how many operational hours you have over 1 year. And there you always call it full load hours that you can have over 1 year. So if you have installed 1 megawatt and you have 5,000 full load hours, then you have 5,000 megawatt hours a yield per year. It's pretty easy. So and 1 year has 8,700 something hours, I think, 700, 600. Um, so and our system has up to 5,000 followed hours, depending on the site.
That's a lot.
That's a high capacity factor. Yeah, that's higher than a horizontal access. Yeah.
Yeah. So if you, for example, compare a coal fire plant, there you have a coal power plant. There you have, because of the um, service cycles and everything like this, you have 4,500 followed hours. If you have a offshore wind turbine, you have, depending on the site, 4,000 followed hours. So what we do is we have offshore wind on onshore sites.
And what's the output?
Yeah, so for now the system is rather small because of the sites we want to go into. So they now have we call it cycle power, because this is it's not like what we know from conventional wind turbines. We always talk about installed power, but we in our industry talk about cycle power. So what you have in a one power cycle. Yeah. And this is a 200 kilowatt system what we have now in the market.
Okay, that's a lot larger than I thought you were at right now. So that a 200 kilowatt machine can help a lot of people, particularly in rural communities or where there's been through a hurricane, just getting back up and running is huge because the load is really simplistic. Lights, maybe cooking, those kind of things, air conditioning.
Yes, so the yield would be 780 megawatt hours a year, depending on the site, of course, again. But that would be enough power for, I think, so just talking German households because I have the number in my mind. So that would be something between 200 and 400 households for one with one chip machine. Yeah.
It seems like the proper solution in a lot of cases. So, what's the deployment plan then? If you have a larger community, would you deploy two SkySails systems? Would you install a larger system? What does that look like in terms of the right approach and the units and to the community?
So what we can see now, so looking at our how we go into the market now. So now we have this 200 kilowatt system, which is actually meant for like all these remote places where we have diesel hybridization, with PV hybridization, all these places like remote off-grid solutions mostly, and mini grids, microgrids. And then next step would be, and this is what we are already have in pipeline, is to develop the next bigger system, which is then also meant for more developed countries because you have a different load, so which you can match. Then, of course, you match better the needs of these specific markets. And then also already planned is next step after that one. So first step would be now something between 400 and 500 kilowatt, and then the next step is already a megawatt system. And this is already planned to do. So this is already in project plans and everything.
So, what does a megawatt system look like in terms of the kite size? Does it expand? I don't know what the math is. Is it square function? How big does this kite get versus a 200 kilowatt system to a megawatt?
Yes, so the 200 kilowatt system uses kites up to 180 square meters. Also depending on the wind distribution. So if you have a high wind side, you use a smaller kite. If you have a low wind side, you use a bigger kite. So you can use the same system, but you just exchange the kite, which is also really great when it comes to material intensity. Then if you look into the megawatt system, the kite size would probably be something between 700 square meter up to 1,000.
How do you okay, so I'm thinking in my this is my traditional mind thinking about wind farm siting and these other things. So of course, like if you hey, we're gonna build a wind farm here. A year before that, we put a mast tower out there. We measure the wind resource. We have a general idea of what it looks like at 10 meters above the surface, and sometimes 50 or 100. How do you measure the wind resource at 400 meters of height? Like, what does that look like? Because I don't think I've ever seen a map that says here's the wind resource at 400 meters.
So actually, there is no. So this is why you've never seen one, probably. Yeah, and this is a really interesting question, actually, because yeah, how do you measure the wind? So nowadays we have what we do kind of the same. So when we do project development, so what we do is first, okay, our customers come to us and okay, we have an idea of a site which would work for us, and then what we do, we have a internal developed tool chain which we use then to do a small, like a really fast site scouting to get an idea of, okay, if this site actually feasible, with weather data which we can just get from databases and everything like it, calculate like is there a business case, like pretty easy stuff. And then after that, next step would be that we go there and then we actually put a lidar on the site, and then we do a lidar measurement campaign. So also wind measurement campaign, but by using a lidar, we can measure the wind far up, far higher, and that's it.
All right. So this sounds really doable. I just did a quick Google search to see what the square meter area of an Airbus A380 is. It's about 850 square meters. So you're talking about a kite that has the wingspan roughly as an Airbus A380, which is it's big but doable. I mean, obviously those airplanes are flying around, so it's not particularly hard to make something of that size, particularly in a kite form. So this seems relatively straightforward. Once you cross that megawatt threshold, then your market expands dramatically, correct?
Yeah, it expands dramatically, and then and even for what then is the step to do is actually to put them offshore, to put them on the floater, because then it expands even wider because what we can do with this technology compared also to conventional technologies which we have on the market nowadays, is that also there the floater can be much smaller because if you compare it to a wind turbine, um, so the wind turbine has all the weight up in the sky. And what does it do with the floater? The floater must be really big because you have to take care of the binding moments, huh? Up in the ocean. Um, and if you not have these binding moments, you don't need a floater which is that big because if you look at our system, all the weight is on the ground. So the only thing you need is actually an anchor so it doesn't swim away because of the kite.
All right, so let's walk through the math of that for a second. So instead of putting out a 15 megawatt turbine and all the, as Joel has pointed out on the podcast numerous times, the complexities of doing that, the ships, the pounding the monopile, all the regulatory aspects,
The material intensity.
Pure cost. Yeah.
the pure cost, right? So you're cutting out all the steel pretty much out of a wind turbine.
Even the rare earths is because, like, if you look at the wind turbines, because they need to take care of the weight, they need the rare earth is because otherwise the generator and the magnet inside for the gear would be would have too much weight, you know. And since we don't have that issue, we can use um, other materials like yeah, other materials which are not that easy, which are much more easy to get, you know. So because we don't have the weight issue.
Okay, so the cost would come way down, the simplicity would be there, the deployment would be easier. Are you seeing interest in this and on offshore applications? I'm thinking, Joel, I'm thinking California.
I'm thinking Gulf of Mexico because now you've solved the hurricane problem. Hurricane's coming, wheel them in, shut them down for a second. Hurricane blows through, put them back up. So you remove that blade problem that we have in the Gulf of Mexico.
That would be great. That would be a great site to actually to develop such systems. And then yeah, and even sites like the coast of Japan, because in Japan you have the deep sea, really deep sea coast, which means that it's really hard to install any other wind turbines because it's too deep. You know.
As this technology develops over the next roughly year or so, you must be ramping up on the factories and the scale and to be able to produce these units. But it does seem like there's a lot of advantage here, particularly on the cost side. Man, even in like UAE, Saudi Arabia, places like that where there is wind, just deploy it, boom, 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 right? Uh, so what does that look like? Are you scaling up at the minute to to take some of these orders because the math works out? It looks like.
Yeah, so actually, we talk in the right moment. So what we do now is actually so we have taken the step to develop the technology, and we have proven the technology also by having the first, also being the first company in our industry to have a verified power curve last year. So we made the proof for the technology that it actually works and produces power. Um, and this year is all about to go into the market. And we do this making big steps forward. So as we have a lot of customer inquiries, and we've not done any outreach from our side, so it's all inbound, um, which is great. But now, so now we say now our customers are actually ready to reserve their production slots. This is what we do now. So they can reserve their production slots, and then we will deliver the system when they need them.
So where can they see a system today? Like if I wanted to see a system in action, would I just go to YouTube? Would I travel over to Germany? Would I go to Mauritius? Where would I go see this live?
So to see them live, of course, it's always good to go to northern Germany or to Mauritius. But then, of course, in the near future, you will see some flying in Taiwan. And then we will extend to the Philippines, and then probably Cape Verde will be next, or French Polynesia. We will see which is faster, and then hopefully also Hawaii.
I love Hawaii.
There we go. That's where we want to go. Yeah.
Yeah, of course. I'm happy to invite you when you are ready to run them. Then take another podcast there, I would say.
That would be terrific.
Yeah, we actually we are just ramping up, huh? We're just ramping up this whole market, and this is really exciting to us.
Every country is different with airspace laws. Now there's some global stuff, general guidelines, right? But there's every country's different. Like there's these you can't fly a kite over 500 feet in the United States. Then you run into airspace and you have issues. How have you guys circumvented or dealt with some of those local airspace regulations?
In our industry, there are different approaches right now, because some of them, if you compare the technologies, there are two different concepts. So the one we use is the textile kite, and then you have other companies which uses rigid wing. Which okay, we have our why we use textile kites is we have a lot of issues why we do that, and not do the other approach. But if you compare them, then the rigid wing companies, they claim that they are kind of a drone because of course they kind of look like a drone, a tethered drone more or less. It looks like an airplane, like a small airplane. But if you compare our kites with them, then well, our kite is not an airplane, so it's not as movable, and so what we classify as is an obstacle.
Like a tower.
Yeah, like a tower. Yeah, like a structure. Um, and then because of that, we of course we need some marking, which means we now also have developed an integration concept which comes with different kind of safety measures. So because what we always have to take care of in using the airspace is that you have to take care about the safetiness, of course. So all the other airspace users, they need to be aware of what you're using as an airspace, which means that you need marking, and the marking could be that you have lightning. It's like a wind turbine. You have every 50 meters, you have some lightning on the tower, flashing. Um, and then what we use kind of the same. So we have a lightning on the ground station, on the mast, and then at the controlled pod, and then the kite is also white and red colored. Um, and then what we also want to implement is a map mark for the airspace maps. For like a symbol for so that you know, okay, there's an obstacle, and then you of course need some awareness campaigns to make all them aware of the technology, and like this also comes with more installations, of course. And then for now, what we try to get is a solution where we use EDDs, danger zones. So like all the pilots are aware of, okay, there's something, but you can fly in, you can fly through. So it's not a restricted zone, but it's like a danger zone. So they even use these danger zones for in Europe. They use them also in other countries for drones, for example, for drone use spaces and stuff. So yeah, that's the way to go now.
In the States, it would be covered under a COA, I think, right, Alan? A certificate of authorization for use. Then that's filed with the FAA. Then they can go from there. But
Because there are buildings that that exist that are taller than what you're flying at today in the world. So you're not the tallest object on the planet at the minute. And obviously, there's hills and mountains and things that are much taller. So this makes a ton of sense. So anybody who wants to find out about Sky Sales, you need to go to the website because there's a ton of great information. And the website is SkySails-Power.com. But they're also on LinkedIn. You can see a lot of Sky Sales information there, and their YouTube channel. Yeah, the YouTube channel is really good, and check it out there. Mark, how do people get a hold of you if they want to acquire one of your systems or see a demo? How do they do that?
So it's actually the easiest way would be just to visit our website and file us an inquiry, or you can just send us a message on LinkedIn.
Great technology, fascinating, and the growth of this technology is astounding. 1 megawatt kites or sails does seem like a way to make more wind energy. Pretty slick. So check out skysales-power.com. Mark, thank you so much for being on the podcast and keep us up to date as things progress, especially if you go to Hawaii.
Yeah, we will do that. Thank you, Joe, and thank you, Alan.